Hi, welcome back to another video on the Formatables Refactor. This video we're going to start our work on the locator. Locator was a bit of a hack when we started. Make sure if we record, and we are. So locator was a bit of a hack when we started. We just tried to get things going as quickly as possible, as we always do. Created a class with the responsibility to create the paths for the artifacts, and it had a configuration that enabled you to change certain aspects of its functionality, basically the variability component. However, as I explained in the previous video, in the past or up to now, it is up to the artifacts to call the locator, which is not ideal really. What we want to do is apply a transform across the model. So one could even question whether there's a need for a locator class at all, given that really what you want to do is for every model element, for every physical projection, we would like to compute a path. Given an archetype, we shall determine what group that archetype fits in. That group will then enable us to determine things like whether it's C++ header or not, C++ implementation, and that's it really. So instead of creating a locator, what we're going to do is we're just going to create a paths transform, and I think that probably will suffice. So we'll start off by copying the locator configuration. Now here you're going to start to see some of the problems why it is that we're moving away from dia. So you would have thought I'll be able to just do something simple like paste this class here and then rename it, but sadly dia does not take into account the fact that this class now is in that namespace, which then means that you'd have to manually go and change the XML of the dia model, which is not ideal. So what we tend to do often is we just manually copy the properties across. Now you may think this is a bit of a waste of time, and there's a point to that, but one advantage of this approach is that you do think about each property very carefully. So a lot of times you end up changing names and improving documentation and so on. But this will all be in the past once we have a text-based model. So what we're going to do is we're going to try to get some space here for these new properties. I think the simplest thing to do is probably to move these chaps here to the other side of the model, I think, of the model properties. This is another aspect that we are quite keen on getting rid of. Once you have a graphical representation, and when you are particularly OCD, like most programmers tend to be, you end up wanting your diagram, your graph to look, your graphical representation to look nice, whatever that means. And that then means that you spend some time playing around with it. What you really want is you will want a function that is applied to the model and just creates a representation, a graphical representation, so that you don't have much choice. I mean, you could have some parameters in that function, that's fine. You can determine certain things, so there's some configurability there, but not too much, so that you don't spend forever trying to work out the best position of things, which is what we do a lot at present. But as it is at the moment, we don't really have that option, so time is spent playing around, I guess you'd say. If this was a development team, I guess your team lead would probably not be particularly pleased that you're spending time getting things in the right positions in the diagram. And that's why we need to move away from this really. Alright, so what we'll do is we'll move these guys all the way back, just to give us a bit of space on that corner. I must say I find this, as my kids would say, quite a satisfying thing. I will miss this one. We have a text-based representation for models, because it is strangely satisfying to play around with models and just put things in the right places and so on. It's not productive, but it is satisfying. I guess we all like visual things. Probably something with our neocortex, I guess. Alrighty, so, and then of course everything has to be lined up correctly, and you know, as you can imagine, you can spend a lot of time playing with these things. Right now then, so, and also we have a new version of Die, as I mentioned in my previous video. I've been using the same version of Die for more than a decade, which meant I was quite used to it. I didn't really want to upgrade, if I'm honest, but as we keep moving with Debian Unstable, it's becoming more and more painful to obtain the previous version from snapshots and that sort of thing. So this last dist upgrade, I just decided to bite the bullet and just go to Dia latest. It's good to see that there is a maintainer trying to get Dia going again, actually. Nice to have a release. It's actually changing, fixing some of the long-standing complaints and so on. But sadly, we are moving away from Dia. Not really to do with the fact that the tool Dia is still a really, really good tool, if I'm honest. And I still will use Dia a lot for diagramming. But I think when it comes to modeling, when it comes to the sort of stuff we deal with every day, it is not ideal to have a GUI as your main source for the models. Text is much better for several reasons. Right, so let's have a look at this then. So we have the facet configurations and the archetype configurations. Now we don't really need to copy these across because we already have facet properties here, and we already have some archetype properties here. So I'm going to assume that these things will be sufficient. Now then, let's go over to the include directory. In fact, to be honest, let's just say this path properties, I guess. We don't really have a locator, so do we have a path property somewhere? Ah, we do. So we already have a notion of a path project property, so perhaps we need something like what are these things then? Path properties. What would you call these properties? I mean, mainly they're to do with paths, directories and so on, but legacy path properties perhaps, because we only need these because we are trying to re-implement the legacy. Or we could say project path properties, and this is something that we will use more and more, the name project, because project is one of our meta model components. What we'll do is we'll do the strings at the very end, because they're all strings anyway. So right, so we have an include directory, we have a source directory, disable facet directory. So we're not going to copy that one across because we already have place for that. And now we're going to have the extensions. We have a backend directory name. Test directory name. As you can see, this is all very straightforward. We're just going to copy these properties. Now see, all these elements you're seeing here, you can clearly, very quickly notice a pattern. And that's exactly the job of Dogen development, is to notice these patterns. You can easily see that we're describing properties that are of a physical component. And these physical components have now got names now, mainly parts. And now, as I said, we can't use Python anymore, so sadly we need to manually update colors, which is actually quite a painful thing actually, because some of our colors are very similar. So F7E. Right, there we are. So as you can see here, we have a location configuration, and now for good measure what we'll do, although I think we do have two stories, C# and C++, but sometimes these stories have to be merged. So here we have fast configure the zero fast directories and then direct. Okay, so we pretty much, this is a superset of the properties for C#, which is really good. This is a good sign that we're going in the right direction. So then what we need is to create a variable. So legacy type containing all properties related to paths, something like this. And then in here we just create a variable for this. Righty, lovely. Now then, annoyingly we need to move these things down a little bit. And I think this will do. Of course you would probably complain about my namings and so on. I mean, just bear in mind that our approach is always to try to get something, capture the properties, try to understand what the thing is, and then as we play with the thing, whatever that thing is, we start to see what its responsibilities are, we start renaming it, and it will eventually converge to a name that has a bit more meaning than perhaps the first thing that comes to our heads. So that's why sometimes you see names that look very strange, because we prefer to just, as long as you capture the entity, as long as the entity is modeled, names could always be improved. I believe in continuous refactoring, really. The difficulty is when you try to spend lots of time against a whiteboard trying to find the right name for something, sometimes they just don't come. So, right, okay, that sounds like a good start. Now the next thing we're going to have to do is we're going to have to, besides generating the project path properties, we're going to have to read them, and also somebody is going to have to keep track of these features. So let's have a look. Here we are. So again, physical model will have to take on the role of defining these features. So we can call these no longer global features, but path features, presumably. Set of features related to path processing. Some suitable bland comment. Again, we don't have our lovely renaming. Sorry, not renaming, but recoloring, should I say. So I'm gonna have to get used to changing colors by hand. Right, so we just need, oh, actually one thing we need to do is to remember to copy things across. Interestingly, we have a generate static configuration false. I think we can get away with setting that to true now. Because we probably will be able to just create a class and read all of these in one go, I should think. So I think we should set that to true. What we probably want to do to start off with is to make sure that we don't inject these features, because otherwise they're going to have duplicates. Let's see if we got something here where we don't inject. Not really. Okay, right, fine. So this will inject the features, so that means we need to be careful to make sure we delete them. And it should be fine, I think. We just need to go to the C++ model after this and then just delete the features from there. So, okay, let's just start the process of copying and pasting now. I'm going to stop making references to the fact that these things should really be text, because life will be so much easier. But there you are. That's where we are now, so there's no point of complaining. inclusion required. No, we don't need that one, I don't think. So probably don't need to copy the variability okay, so this is where we have to be very careful that we're not distracted and miss something. So this guy here has a default value. Clearly going to be text. There's a comment. It's not exactly the most scientific of processes, this exercise, but such is life. It's fairly relaxing, I guess. You can imagine we have a much better way of modeling this now, so parts will provide us with a great improvement. But at the same time, I quite like the way we do things, because the fact that this is a project that we do on our spare time enables us to take approaches that are not very practical if you were doing this, say, in a company. Because at the end of the day, I mean, everyone is used to working on a sort of development house, and you know how things are like. You need to get things done. Sprints are about delivering things to the business, and there's many things in the system that you know need to be tackled, but you need to balance that against the priorities of the business, because at the end of the day, the business is funding your development, which then means that it's not so easy for you to do the sort of re-engineering and refactoring tasks that you want to do. It's not necessarily a bad thing, to be honest, because of course we all need guidance. We all need some kind of way, some function, some fitness function that tells you what's important and what's not. So perhaps the fact that the business tells you that, whatever that business may be, it's not necessarily a bad thing per se. But it does mean that it's very difficult to find business sponsors that take into account refactoring as a really important thing to do, and the learning about the model that you're working on and so on. Which means that it's very difficult for a normal company to do real R&D these days. It's not so easy. If you look at companies like Xerox, one of my sort of most how should I say this? Oops, sometimes you get distracted. Xerox is sort of one of those companies that I respect a lot. When I say Xerox, of course, I'm talking about Xerox PARC, not Xerox, the company today. But Xerox PARC is, as you probably are aware, a place where pretty much most of what we call modern technology was invented. And the reason why they invented so much technology is really because they allowed a bunch of nerds to just get on with it. Very little supervision. It's only possible because they had unbelievable amounts of capital that they could play with, and I'm sure there was a lot of money that was wasted, but at the same time they invented modern computing as we know it, and I don't think there's going to be many Xeroxes now. So where are we? Enable unique file names. Oh, interestingly enough, we don't seem to have enable unique file names. Interesting, no? A lot of stuff to do with aspects, standards, helper family, and streaming properties. So let's just do a quick double check. Headers output directory, inclusion required, source directory, include directory, test directory, template directory, header file extension, implementation file extension, templates file extension. Now, enable unique file names, we put that there. And I will take a punt here. And let's just say that I think this may be useful in the future. So let's just put it here for now. Not quite sure how this is used, but give it a punt. Right, so now then, This is really where it's annoying, because there's no easy way to now just say please move everything by 1. You end up having to spend some time playing with the diagram. I'm just going to accept this change as it is for now. Right, so then, interestingly enough as well, artifact should be a lot lower than it is. You could spend the rest of your life just trying to organize a diagram, I think. You can clearly see why it is that we need to move away from this representation, I think. It's very tempting to play rather than do work. Yep. Bit more satisfying, I think. Now then, probably, you see, this is also a sort of a snowball effect, because once you do a few, then you start to think, oh well. And the other thing, of course, is you have to remember that all these things change over time, so you may spend some time now doing this, only to figure out tomorrow that actually this type is no longer required. So really, logically, you should not spend a lot of time getting the diagram in the right shape, because it never stays with that shape for that too long. But sadly, it's very difficult to avoid doing that. Alright, there we are. It looks more or less straight now. So now that we have our type, and I'm not entirely sure why. Yes, that's better. Now that we have our type, here we are, that pipe is there, it's modeled correctly, project path properties. We are now starting to refer to things as project. I mean, soon enough this model will be renamed to project model. But not yet, we need to wait until we get to that point. Also find that with the videos you slow down a lot in terms of the brain power. Okay, cool. So let's just not dwell on this too much. We have the property paths. We've created our features. If we just generate this as is, it's going to inject the features. Once you do that, C++ model is going to complain that these features are duplicate, and then it will break. So for a laugh, what we'll do is we'll just try to do that, make sure our theory is correct. So let's just go up to our compilation window, let's just generate all models, have a break. So it's like we repeated one of the items. Not obvious to me. Ah, okay, so there's a duplicate qualified name for the configuration tester. Ah, okay, right, so I think what probably happened here is our copying and paste was not very good. Let's just double check that we didn't copy the wrong things. No, that looks perfectly fine. Okay, I think the problem actually, this is just, this is good. Dogen is just telling us that we have the same qualified name for a configuration, and I think it's actually not very obvious where this is coming from. It's actually trying to tell us that test directory name is duplicate. I'm convinced that the reason why is because we have the same element, same configuration element in two different places, and as you can imagine, it's coming from here, it's coming from there. The model element itself, of course, has got a different name, but underlying it, it's pointing to the same configuration, if you see here. So I suspect The problem is coming from this guy here. However, if I am right, this would only be a problem when you're generating... interesting. So it's a problem even in physical model itself. No, I think somehow we made a mistake somewhere. Let's go back to the physical model. Normally there's an override that could cause this kind of problem. Actually, one thing we should always do, sadly, you know, as you can imagine, Dogen is at the moment just a bit of a research prototype, so it's not exactly the most user-friendly thing in the world, and it's really not designed for the end user just yet. So a lot of times it's easier to just do lots of logging. So if we just do a generate Dogen.physical dia, it's just going to generate the model. Go to the log files and let's have a look at what the physical model log file looks like. So, see, as you can see here, we seem to be extracting everything fine, except we seem to extract text directory name twice. That would imply really that we have text directory name twice. Now, it could just be that I'm actually, my site's not what it used to be. I don't see two of these test directory name here. Only the ones. But interestingly enough, see, if they were coming from two different places, it would make sense. They're both coming from the physical model. The only other option is that someone else, let's just make sure that there's no slight differences in the name. Both of them are project path properties. It's very, very confusing actually. Okay, well, this is very strange. What we'll do is, just for good measure, what would happen if we delete that guy? Actually, before we do that, let's just have a quick look at the diff in Git. It's always helpful, just in case. So if I just look for test directory, it doesn't even, it's a tests directory perhaps. Yes. So tests directory name. Okay, that's very interesting. So I see that coming up 3 times even. It's most interesting. You see that attribute coming up 3 times in the physical model. But I don't see that visually here. Okay, right, sorry. This is just me being silly. So this is one of the problems of doing videos, really. If I wasn't doing a video, I'd be a lot more focused and I'd be paying attention to what the thing's saying. So let's just go back. I mean, the Dogen told us everything we need to know. We were just being silly. So it says here, duplicate qualify name for configuration. Okay, this is not ideal the way having the duplicate at the configuration level, but nonetheless, it's quite clearly saying here, project path properties. Now, these are the path features. He was talking about this guy. So it's clearly saying that. So really what we want to do here is we want to say, let's just create a quick story and say something like this. Detect duplicate attributes via validator. Still not able to put my attributes, annoyingly. At present, if we add duplicate and add two attributes with the same name, we get a weird exception in the guts of the variability layer. And here what we really mean is let's just copy this bit here. Guts of the logical model, to be fair. And we just leave this here. It would be more user friendly if we had a validator, probably even at the codec level, that throws if there are attributes with duplicate names. So in effect we just spend a pipeline just goes too far down in the processing, and then because it goes too far down in the processing, the check we get is really not very nice. And then we could just add this story here to our technical debt. At some point we'll get to it. For now, what we need to do is the logical thing and get rid of one of these. We should also make sure we did not miss one, because since we decided to duplicate one, that could be a sign that we missed the real one. So let's try again. So it includes headers output directory. Interesting enough, I don't see. Okay, sorry, copied the wrong thing. But interesting enough, we have a headers output directory. Oh yes, I now remember. This headers output directory is being modeled somewhere else. Okay, here we are. So what we're going to do as well as part of this exercise is we're going to clean up these extraction properties. They shouldn't really exist. So just say merge extraction properties with whatever these things are, project path properties. Right, good. So that explains that guy. Inclusion required, we don't need that. Source directory name, header, file extension. Okay, to be honest, this is difficult to compare this with these. We just go back to our previous comparison, which is not exactly the best, but it's easier. So include directory name, source directory name, disable facet directories. We seem to have removed disable facet directories. See if there's a reason for that. No, I don't think there is a good reason for that. So perhaps that was a duplicate. Well, definitely should be here. So let's just make sure we put it here. And for good measure, we'll put it next to source directory name. Disable facet directories, add a file extension, implementation file extension, backend directory name, test directory name, template file directory, finish with unique file names. So we don't really have any unique file names, but we copy that across from the other chap, so I think that's fine. Okay, cool. Now then, we leave that for now, just to avoid causing too many problems in one go. And in theory, I think we don't even have to worry about it. We can just generate all the models. Now what you'll see, and this is the point I was trying to prove, we've got logging enabled, so that's why it's so slow. What you'll see now is if I was to attempt to run all tests with this, we expect to see failures. And the failures would be because we are trying to inject the same feature twice. While this is doing its thing, let me just demonstrate. The features are here, such as the headers output directory, for example. And then if I go to the logical model, well, as it turns out, actually that's probably not the best of options. So, so as you can see here, this is what you expect. It's precisely what everyone would expect. But before we do that, let's also do something else. Let's make sure we copy across the headers output directory, because we didn't, and I think we do need these. Oh no, we did copy it across. Okay, good, excellent. Alright, now then, because we know that's the case, what we need to do then is we need to say, please C++ model stop generating these features, given that they're already being generated elsewhere. So, enable unique file names, I'm sure we've done that one as well. And disable facet directories. We have facet property somewhere. Ah, but these are top level. Okay, I'm gonna take a punt here and say that we also need disable facet directories. I can't see it here at the moment. And so as you can see, when we said this was easier, it's not necessarily trivial. It's just a little bit better. I'm just gonna type false there. A little bit better than dealing with absolute abstract stuff. It's a little bit more tangible. You know, copying things across, sort of stuff that any person can do without huge amounts of training. And the second thing is, clearly we're going to have similar properties in C#. Let's have a look. No, it turns out we don't. Excellent. Right, now then, what we'll do is we need to, hopefully we did not build this entire code generator. So let's just generate the whole thing. Should probably disable logging really. And then run the tests. And meanwhile, we'll just make sure logging goes back to where it was. And now let's see what happened to the tests. And as you can see, this is progressing quite slowly. I mean, we're almost an hour into this. And yes, the code generator actually works. I mean, we're getting differences, which is what you'd expect. So now let me just do a couple of things. So if I convert Dogen dot physical.dia to JSON, and if I convert text dot cpp.dia to JSON, and indent both of these, so these are the sort of the JSON representations that we got at the moment. As if you recall, that we're still supporting multiple codecs at present. We probably should really get rid of JSON, but we'll do that when we do dia. Right, now then, we have a slight problem with our JSON representation. So it's a little bit of fiddling. Now then, so supposedly this should help us with our tests. So in theory, we are still defining the same features, we're just consuming it from somewhere else. We were not using, yes, exactly. So as you can see here, everything worked exactly as you want it to work. So at this point in time, one can easily commit, because everything's green, and say physical move locator related properties and features from text.cpp. And the second thing we want to do as well is every time you run all tests, it's good to run all tests, but you should also build the code generator itself and code generate all models with the latest code generator to make sure it still works. As you can see, it still works. And you should also, of course, go to Git and make sure there are no diffs. That's really good. Okay, so at this point in time, we generated the features and the new properties. And it should be fairly simple now to just read these properties from the features because they're almost one-to-one mapping. But actually, for good measure, what we're going to do is, since we are code generating, we were just going to finish the job and say well, to be fair, I think headers output directly should just be a string, given everything else is just a string. And all of this is just temporary anyway, so I'm not being exactly super careful with all this stuff. And now that we've got rid of that type, which was annoying me, I can start moving things around a little bit. And now we can see why, what I was saying a second ago about not wasting too much time refactoring the diagram, because of course the diagram constantly changes. It never stops changing. Which means it's really time wasting, but what can you do? Righty. It's almost like the worst possible combination, having a person that is very OCD and having a diagram that needs to be maintained. I think that OCDing is telling me we should shuffle these guys here. There you are. OCD is now satisfied. Hard to tell. It would be almost impossible to create an algorithm that does whatever it is that we do manually to these diagrams, because it's so arbitrary, I think. Just moving things around until you're at peace with yourself, I guess. There you are. So, model. Denormalize properties, and away you go. So then, we're going to regenerate this guy. Process should by now be familiar. See, if I got logging disabled, actually, one thing we forgot to say is we don't need extraction properties anymore. Of course. What I was going to say is, yeah, if you've got the logging disabled, then it's such a easy thing to do to just generate everything, really. So let's just update our JSON models, as we always have to do. And then we will just stage all of this. Now we're not going to commit, of course, because as you'd expect, when we run tests, and this is another reason why I should really have a suite of tests that is very quick. I mean, C++ of course is not quick because you have to compile, but it's still important that you can run all this stuff in seconds, minutes most. Right. Now then, we are going to have a slight problem, which is... Yes, we made a mistake actually. We can't do this immediately, because if we do that now, we don't have a transform that reads all these properties in, so that, yes, again, this is clearly a problem of doing these things in the video. Yeah, this is not going to work. We need to put the extraction properties back, because we still haven't got a transform that is reading the new project path properties. So first we need to do that, and then we can put the extraction properties back. So what we're going to have to do is, quite sadly, is going to have to recreate them. I mean, I could just of course undo, but I'm not going to do that because I already got my diagram in the right shape. So what I'll do instead is I'm just going to quickly hack extraction properties as they were. And I'll put this guy here. roughly our extraction properties were. I'm going to leave them there. And bit of a hack really, but and put it back in the model. And hopefully have to add them again to the JSON model. Right, now then, yes, so now Dogen is complaining. Now what we expect to see now is just trivial changes, which is exactly what you're seeing. Doesn't really matter. We are seeing the addition of the project. Oh, enable unique file names. Yeah, so yeah, that's fine. So we've added headers output directory, which is what we want. So let's just basically say physical copy extraction properties to project path properties, which is fine. And then if all goes well, when we try to run our tests, nothing bad will happen. So we will do this, just not just yet. When it's ready for removal. However, first need our transform. So we already have not quite an hour, but so the objective of this video then will be to try to see if we can hook it in this transform, read those properties, and then get rid of the extraction. So we will get rid of the extraction properties transform. I wonder if MetaModels property transform already probably has everything we need there. That's not quite what I meant to do, but it's fine. Probably not test pass, so we're not going to bother with that. Rerun all these guys, make sure they generate, make sure there's no differences, all good. Let's have a quick look at the MetaModel properties transform, and in there we shall see how this works. Yeah, so as you can see here in the MetaModel properties transform, we already have a load of hackery going on, reading stuff. C++ headers output directory. Interesting. Okay, interesting. We have a C++ headers output directory here. And then enable backend directories. But I'm not sure this is being used. Yes, okay, so it's not being used. Fine, good. So let's just do a quick refactor then. Backend, enabled backend directories. That is probably I think we should really move enable backend directories to this guy here, and then we should really have enable backend directories as a feature. So if we look back at CPP, we don't seem to have a feature for enable backend directories. Now I wonder why. Let's have a look at that feature. Don't even seem to be using it at present. Right, there it is. There's a feature, and it's called MASD.physical enabled back. Enable or enabled? Enable. Now let's go to the physical model. There's clearly a modeling error that's going on here. What is the enable backend area? File system. Right, now then. Okay, we've probably made a modeling error again. So look at these guys here. There's a file system set of features, there's a path set of features. Now this is a classic modeling sort of problem that you always have. Sometimes you want to do things quickly and don't think properly. So we're modeling two very similar things. The file system properties seem to be modeling things to do with file system, whether force writes, whether delete extra files, delete empty directories and so on. But it also models the enable backend directories. Now enable backend directories is clearly something needed in order to compose a path. So what we're going to do then is we're going to do a quick hack here, and that hack is going to be to move we have a slight problem because enable backend directories is actually a global property, so not specific to a backend, whereas the path features are actually specific to a backend. So if you see here, this is C++. Really, we should call this CPP path features, really, because all of this is C++ specific and all of this will be removed once we model it correctly. Whereas that's good, this will stay, except for enable backend directories. So what we're going to do instead, and we've already checked and we already noticed that there is no such hackery going on in C#, which is good. And that's another reason why we have two different languages, just so that we can contrast and compare the differences. But you can see here the global features here are much more straightforward. So therefore, what we're going to do is we're going to do a slight hack. We are going to say that enable backend directories really is a property of the project path, because just like everything else in here, it's just a temporary thing that we're going to get rid of at some point. So we get rid of it from here, and not what I meant to do at all. Right, so see what we're doing here. We're just trying to say, okay, we know for sure that enable backend directories is just a hack, right? We will leave it there, just like extraction properties. Bit of a hack, but we leave it there. All of the stuff that is deprecated will stay here. We know what they are, and then we can just remove them all in one go. We'll leave the feature as it is, because these features sit in a different place. This is C++ backend features, these are not. So that's fine, but the property will go in there. And that then means that I can get rid of all of these top level features, and I can just read the new features using the generated code, and then I can quite easily map the project path properties from the path features, and that's it, job done. So one more generation to go. This generation will cause problems because we moved something. So we can just very quickly try to run the tests. That's going to break, and it's fine, we expect to break. The glass is a bit annoying, so and there's the break we expected. And if we just say, please show me where the break is. Right, so we now need to say something like path properties. Okay, and presumably that should work. Didn't I said path properties? I meant path properties. I did call them path properties, didn't I? Project path properties. Righty. Then keep trying to. Oh, sorry, yeah, you can't see the compilation window. Now, presumably this will break as well in the chain. Similar problem. At some point, we will be fine. I'm pretty sure why this is EKD. Should be EBK. So let's just fix that. Enable backend directories. Right, and with this we seem to have solved all our problems. So let's have a quick look at what Git thinks. Right, so then what we're now going to say is move enable backend directories to our properties. Okay, all good. Now this is very good because, and of course as always, let's make sure we have a code generator, and let's code generate everything with the code generator, make sure nothing breaks. Excellent. Now then, everything is in the right places. We've moved everything to path properties, which we already wanted all this stuff to go, and we can easily now return to our lovely transform, and the transform would have been something like metamodel properties transform. And now we can say something like this. We can say, well, do you know what? I don't particularly care for the top level features at all. I would like you to just create one single method. So at the moment we have a read a backend configuration, which reads the configuration for the backend. We just need something like, actually we should just use doxing here. Read the project file. Oh, actually we don't really want to read the configuration. Oh, yes, okay, read the project. This is just a bad name really. What we really need is the properties. But we follow the pattern here. We really need to decide what we're going to call these things, whether properties or configuration. So we should be able to say something like obtain. Again, these names are really not ideal, but I just have to keep going. Right, so then this is going to be a bit different because I'm going to say something like entities, project properties, then give me a configuration, but of course can't just do this with the configuration in this particular case because you're going to need a feature model so that we can read these features, and this will probably be static as well, don't need any state. Right, now then, now all the errors are going to tell us what to look for. This is all stuff we don't need. Such as this guy, and right, so obtain enable backend. Right, so we're not going to delete this just yet because there's logic here that I want to preserve. So let's just comment this region here. Obtain enable backends now does no longer exist, so this can go. What else? So we have to be very careful what we're saying here. So first we obtain enable backend, and then we compute it. I think it's fine. Right. All good, I think. No references to a level feature group other than that one. Okay, cool. Now then, just after the make archetype feature group, we need to create a new function, which is this guy here. And this will be very, very simple. All we do with this guy is to say, please, can you read the configuration. So this is going to be something like include Dogen.physical types and features, and then we're going to have the path features here, and we will use this guy here. I don't quite remember the syntax. How you use features, and I don't think we are using any features here. So what is going to happen is we're going to have to create the features, right? So let's think of a transform why this is already happening. Perhaps file system. So I wonder where the file system transform is being used. Let's just create another area here, 7 perhaps. Don't need all this. Let's just have a look at the physical. Quick RG, and then let's say, oh, I'm just going to say file system. Anything on physical file system. Okay. Oh, there we are. No, that's the transform itself. Okay, that wasn't very successful. So features file system, perhaps. Right, there you go. So this guy here. Right. So this is telling us how we should use this thing. It's very straightforward. So we just need something like. So the feature model we already have, that's good. Features part, features, this guy here. Make the feature group. And we read that from the configuration clearly, as you can imagine. Right, so what are we trying to do then? We're trying to generate these guys here. Right, so we generate these guys here. The static configuration will contain all the stuff we want. It's a shame it's just a little bit too big. So we can just basically use all of these guys. And now then we could say, well, and now, as you can imagine, we will go to our commented out code and say, right, so we need to know how many backends are enabled in order to compute const unsigned int total backends enabled, something like this, right? Let's just put a marker here for a second. Right, and another marker here. And now we can easily say all this stuff. Right, so we're going to say something like this. Huh? We already have accounts. Do the logging, I guess. So required is going to be something like this. Backend directories are required. And we need a comment. Well, actually, a system comment region, I think. So requested, right? So we need requested, and requested is going to be scfg dot enable. Ah, yes. Okay. Right. Bit of a bummer. So if you remember, we said this feature was somewhere else, didn't we? And because of that, this is going to, sadly, going to require still some hackery. Just don't seem to be able to get away from hackery, I don't think. Actually, I wonder what would happen if we made a bit of a mix and match and put a feature from a completely different location somewhere else. So this feature should really be in enable backend directories, should be in MASD.physical because it applies to anyone, not just C++. These features here are all C++ specific features, so they are inside of MASD.cpp. However, for the purpose of this exercise, we are, well, actually there's two ways of doing this, and I think we probably have to do it a sensible way. So sensible way will be to bring enable backend directories back. It's quite sadly, I think. I'm gonna have to. Well, one thing, if you really cool thing in Emacs is you can revert to diff, and then you can apply, so that we don't have to be faffing around with things. So let's just apply this. And I mean, this is really disappointing. I didn't really want to bring all this code back, but not much you can do. And now, yes, and now here, don't think we can just apply because there's a lot of stuff here, but we largely want this guy. Right, so this is sort of a one big fat hack, but I must say it kind of makes sense. I will explain a bit better in a second why we need to do this. And there we are. Right, so we've gone back to having to obtain separately the enable backend directories. We've gone back to also having a feature group and all that bad stuff. We can't use the generated feature group anymore. The reason being that sadly we have one feature that's coming from elsewhere. This is really not nice, but like I say, sometimes you just have to do things because they need doing. It's important not to get too sidetracked about visions of perfection, because at the end of the day we need to code that actually does what it's supposed to do. So now this diff is no longer very useful, so I'm just going to say, please show me how this thing looked like the last tag, which it does, and then I'm just going to quickly see what I want. Yes, that's correct. Right, there we are. This should be the diff. It's got a whole lot of other stuff we don't care about, but it doesn't really matter. Top level feature group is all we need here. This guy here. And we can just drop it where it was before, somewhere around here. And then we will no longer require these two guys here, but we need part of it. Right, now then, so what we need to do is In order to do this, somebody will have to obtain the enabled backends, which we called enable backend directories. Right, cool, that's what we need. And this will just give us a bool. And I think we could just get away with then say const bool enable backend directories, const bool. Right, I actually think. And yeah. Oh, sorry, I meant to say const bool enable backend directories. Righty. Now then, let's just move things around slightly. I think this makes more sense. Yeah. Perhaps. Given we're calling it. Yeah, exactly. Right, so then, what are we doing then? So, somebody around here will have to call something like this, and then we also need to know how that size was being computed. So I think it's still here, commented out somewhere. And size is this. So now we could just basically say obtain the path properties. I don't know, first just start with some random comments. So here's the count. Const auto enable backend directories. This is clearly not what we want, so I'm just gonna do it by hand. Obtain enable backend directories. Now I need some kind of feature group. Right, so I think, yeah, it's not gonna work. So we must start obtaining some feature groups here. There we are. So I suspect there would have been a top level feature group somewhere around here. Let's see if I can find it on the previous version. Or am I close it? Here we are. So I presume if I look here, I will find the top level feature group. Right, so what we did before was we computed enable backend directories all by itself. And to be fair really, if you think about it, this probably still makes sense actually. So okay, so to cut a very long story short, what we're going to do is we're going to do what we did before, but we're just going to return this as a variable, and then if you just supply me that value, see, this is a much better way of doing it. So just compute it just like we did before, obtain the value, and then pass it over to this guy and remember it in these properties, right? So the logic we had was actually not that bad. It was just not kind of working together. So we'll stick to this, and we'll say something like so we must have a compute. Right, we still have it here, so we'll stick to that. We'll do that, and then I would like, instead of computing and updating the MMPs, I'm going to actually take the MMPs and return an unsigned int, which we will see hopefully in a second why this is much more logical. Hopefully. Okay, so now then, what we're going to do, we're going to basically say, go to the MMPs, obtain this guy, do the count, figure out what's required, what's not, and then interestingly enough, we are updating a cached version of the backend properties with the name of backend directories. So, well, if we are already doing that, then so my clever idea is perhaps not so clever. Let's just then say, okay, fine, do what you need to do, and exactly, this is much better. Let's do what you need to do, update this guy here, no one will mind, and away you go. And then we will call you exactly as we did before. The only difference is we shall obtain the project paths first before we do that. So populate path properties. Now we're not going to need accounts, so now the path properties become a little bit different, right? So populate the path properties. Now we're going to say, okay, I need a feature model, need a configuration, but I don't care about either of these things. Somebody else will deal with that. Okay, and which then means that I can just say project path properties, and now that's just going to be something like feature model and the configuration presumably. Okay, and this will make life much easier because now when I'm trying to obtain project path properties, I don't need to worry about any of the backend stuff. Somebody else will populate that for me, create the feature group, blah de blah de blah. Don't worry about any of that. Just make sure you create this guy here, and an R. And now all I have to do is quite literally, I mean this is going to be very, very simple now. I just need to make sure I copy across the variables. So start with include directory name. That's just all going to be exactly as per configuration. Ideally with a very similar name, and the bingo, Bob's your uncle, right? So with this, what we've done now is we've got all the stuff in the right places. Now, interestingly enough, because these things are so similar to the locator configuration, part of me is now saying, once this is done, we probably should try to delete these guys here and supply the MMPs to the locator and prove the locator can work off of them. Because if the locator can work off of them, it means that we've captured everything right. And then we can worry about moving the locator as a second step. So that sounds very nice. Cool. Just a way to validate things as you go along, really. Now then, that's source directory name. Source directory name. It's going to be a bit boring because all we're going to be doing is copying things. Disable facet directories. I'm sure there's going to be a problem somewhere. And followed by header file extension. Followed by the implementation file extension. I could type, this would be a lot quicker, I think. Followed by the backend directory name. There is no backend directory name. Interesting. Well, we knew that something interesting was going to happen here. So the problem with the backend directory name backend directory name is going to be a C++ property, presumably. Okay, let's just hold here for a second. Put a comment. Fix me backend here name. Okay, now we'll keep going. The other ones are going to be easy, I think, because all of these are going to be read from the configuration as is. We'll do as well as save time. We will copy this guy here. So templates directory name, templates fat extension. Enable unique file names. Yeah, oh, I think somebody's talking to me. 1 second. And enable unique file names. Where are we? Headers output directory. So this is now reading all this oh, sorry, I forgot that. Prepared one earlier. So seems to me LSP has gotten confused a little bit. So I would have thought we'd have had this output directory. Bit of noise coming from downstairs, I'm afraid. Yeah, we do have headers output directory. Not sure why that's not working. Sometimes LSP does get itself into a bit of a state, to be fair. So can't rely on it all the time. It's getting a lot better, to be fair. And then finally, enable backend directory, which is somebody else's job. Okay, cool. So now then, the path properties, and this is probably going to be the end of this video, given that we already are 1 hour, 30 minutes into it. Now, what we've done, what have we achieved here? We've managed to read the configuration from all these properties and populate all of the legacy properties we got here, except for one, the backend directory name. We'll leave that for a second. And then compute. Right, correct. So that's correct. We were faffing around with this, and we changed this from void to something else. And now, hopefully, it will all be sorted out. So let's try to see what happens if we build. No, nothing particularly bad's going to happen right now, because of course all we're reading is a set of properties no one's using. Oh, actually, unless we do something really silly. There we go. So headers output directory. Okay. We should have called this C++ headers output directory. Let's just quickly regenerate. Run all tests. And as expected, we have an error. And there we go. To be fair, this is all legacy stuff anyway. Let's just use a consistent name. We either rename everything or we don't rename anything, because otherwise this is going to become very easy to get lost. So we'll just do a quick generation, conversion, indentation. And get rid of that chat there. Right, now then, let's see what our compilation tells us. We would expect to see fairly straightforward pipeline now, reading the properties. Unless there's errors, of course. Of course, we just literally changed something and forgot to update the corresponding variable. Good when we have great memory. So as I say, what did we achieve in this session, right? So we're trying to read this project path directory. So to recap what's happening, take any model, for example, take the C++ model. Actually, C++ model may not even be the best one. Let me just show you with a different model. Let's go to one of our test models. We have a model called directory settings, perhaps. Of course, what we really want is the model itself. Directory settings model. Now here you can see, let's just get rid of all this nonsense. Here in this model you can see the use of configuration quite heavily, and it's configuring a whole lot of stuff. But you can clearly see here directory names, source directory, all is being configured. This is all supplied as configuration. So what is this doing now is this thing here is a class, a generated class that knows how to read that configuration into memory, and then there's another class we use to represent the object model. Now of course you may ask, why don't we just generate everything in one go? And that would be nice, but that's just not how the code generator works at the moment. So unfortunately we have to manually create that sort of a POCO to represent the configuration that we just read. Nothing stops us from actually doing that, except we haven't had time. Now, it seems like we still have a problem. Let's just go back to that settings and see what was the headers output directory. So we're having at the moment a problem finding CPP headers output directory. Just out of curiosity, let's have a look at what we thought that was before we did this refactor. In fact, it might even still be there. There we are. Oh, interesting. So we thought it was MASD.cpp headers output directory. Well, that sounds quite logical. So, why can we not find it, I wonder? MASD.cpp headers output directory. That actually looks pretty logical to me, so it seems like our attempt to fix things actually broke something. So let's just return to the previous state. I was hoping we could complete this fairly quickly, but it's never the case really. So what we'll do is just try to resume the naming that we had before we started trying to be clever. Now let's look at the error a bit more carefully and see why the feature is not binding. What's happening at the moment is we're looking for a feature, the feature is not there. Okay, fine, we expect these errors, that's fine. Just rename. Should be fine. Now the problem is someone, somewhere, is looking for a feature with a different name. Sure why that would be, because configuration. I think what may have happened is we may have forgotten to make these things optional. Yes, okay, bit of a bug here. So I don't think we copied the optionality when we copied things across. Interestingly enough, none of these things seem to be marked as optional, presumably because they have default values. Okay, no worries. Let's think about this for a second. Could it just be that the headers output directory had a value prior to this? So in other words, if I was to look at a default value, that is, of course. If I was to look at my model, and where am I? We reverted so many things that I'm not quite sure where we are anymore. What's going on? A bit confused at the moment. I expected to see C++ headers output directory to be in the C++ the physical model. And I expected it to have a default value. Clearly it doesn't. But it should really have a default value, right? If you think about it, it should have a default value. So then the question is, did we just by mistake, as part of these refactoring, somehow got rid of the default value? So what I don't understand at the moment is why don't I see diffs in the model, but let's just ignore that for a second. Okay, that doesn't help. So if you go to the previous commit, yeah, so in here we should, so if I just look for the changes in the C++ model that we did a second ago, you can just use JSON because JSON is easy to spot things in. Here's the headers output directory. Is there a default value here? Not that I can see. So it's called headers output directory. It's got a nice little comment here. Let's see if we copy it across as well. One thing we must be very careful is that we are looking at the right thing. Is this the feature? Yeah, it is a feature. See, everyone else seems to have a value. But not the headers output directory. So the problem seems to be at the moment is that headers output directory is not an optional feature. It's a mandatory feature because we didn't mark it as optional. It doesn't have a default value either, which means it should be there. Now, I can perfectly well understand why this is breaking now. It makes perfect sense. I mean, if you don't supply it, then, well, it's going to be an error. But what I don't understand is why did it break? Because, of course, we should have kept the same logic, the same semantics as we had before. So, clearly, our copying and pasting wasn't entirely successful. I would have thought that if I look at the C++ model, I see why it's easy to see this in JSON, but sometimes one has to. So if I look at my C++ model, if I look at the properties of this thing, it does not have a value. Right, I'm thoroughly confused now, I think. I would not understand why it was this was working before. Unless the problem is not so much about the property itself, but how we were reading the property. So if we go back to that transform, meta model properties. Right, so what's probably happening here is if we look at the meta model properties transform as it was in the past, we should see that output directories. Yes, so you can see here, this is really not a very good way of doing things. In fact, it's a very bad way of doing things. So instead of marking the feature as optional, we made the feature optional by checking. This is really, really bad idea. What we should have done instead is to say this is an optional feature, and we should mark it as optional. So all these guys have default values, so they're not going to be optional. This guy is optional, so we'll take this side. So the real way of doing this is if you have a feature that's optional, make sure the metadata tells you that it's optional, rather than all this faffing around in code doing the optionality, because of course bad things will happen, which is exactly what happened. So what we'll do now is we'll annotate the feature correctly as optional, and then what will happen is when we attempt to read the feature, because it's optional, it will well, actually I wonder what will happen. It just works, and the reason why presumably is because, let's just look at the type of this guy here. It's because it's a string. Presumably this is just going to come back as a string. So if it's not there, then it just returns a string, an empty string. Okay, this is fine. This makes perfect sense. Okay, cool. So that is it. Okay, so what we've done, I mean, this was a bit of a long one. Should have been only an hour, but it's almost an hour and 40 minutes. So as part of this, what we've done is we've updated the meta model properties transform to read from configuration all of the project path properties, except for the backend directory. Now that needs a bit more thinking. We now know the features are correct. That's all good and fine. So we just need to sort out the problems for the project directory and then try to replace the locator to start using this. Okay, so that's all for this video. Thanks very much for watching.